Assalamu alaikum. Today I am going to present a part of my study titled Sol Gel Bioactive Classes Beta-Tricalcium Phosphate for Potential Application in Dental Pulp Tissue Engineering, a preliminary study. Myself, Mamun Sujon, I completed Bachelor in Dental Surgery from University of Dhaka. Later on, finished my Masters from School of Dental Science, USM. Currently, I am pursuing PhD in Advanced Medical and Dental Institute, USM. Introduction is an imaginary interdisciplinary science aiming to develop strategies for regeneration of damaged organ and tissue. Advancement in molecular biology field and stem cell technology are uncovering new horizons in therapeutic possibilities for tissue and organ replacement. This field of science is grounded in interplay of three essential components. Scaffolds. Typically, biomaterials used to fabricate the scaffolds to deliver cells that may enrich with growth factors. In an ideal situation, the scaffold should be biodegradable and combined with cells that can expand upon implantation. Secondly, responsive cells are generally stem cells. They are undifferentiated cells with varying degrees of potency and plasticity, capable of both self-renewal and multi-nucleus differentiation. Stem cells are isolated from several tissue including brain, skin, hair follicle, skeletal muscle, bone marrow, and dental tissue. And finally, morphogens are proteins that induce cell signaling, influencing critical functions such as cell division, matrix synthesis, and proliferation. Due to anatomical arrangement of pulp chamber, the dental pulp has minimal collateral blood supply, impairing the ability of immune system to combat infections. Nevertheless, when teeth suffer injuries such as trauma, caries, carious lesion, periodontal and periapical abscess, it may lead to dental pulp undergo irreversible pulpitis or necrosis. Generally, in such situation, the conventional endodontic therapy is indicated. There are significant drawbacks despite the positive results of endodontic treatment. The endodontic treatment tooth causes loss of significant amount of dentin that leads on non-vital and weakened teeth. Subsequently, a post-crown or bridge also responsible for severe vital tissue loss lead to broken crown during mastication pressure. Periodontal pathologies is one of the common pathologies associated with crown and bridge. Due to lack of nutrition, the teeth become weakened, which may lead to fracture or broken teeth or loss of teeth. World Health Organization stated more than 95% adults have dental caries, which often leading to discomfort and pain. For adults in Malaysia from 1990 until 2000 showed that dental caries is increasing with the age, which may lead to sensitivity, oral pain, fracture of teeth, or loss of teeth. Root canal followed by crown or bridge is treatment of choice in case of pulpitis or tooth loss. However, all these options are only temporary. Crown and bridge may fracture, become loosened, and need replacing due to patient factors such as heavy smoking habits, poor oral hygiene. Currently, various dental material exist as root canal sealer such as silicone, mineral trioxide aggregate, calcium hydroxide, polymeric based sealer. The primary drawbacks of resin or silicone based sealer is their lower bonding capability with dental pulp tissue and shrinkage behavior. There are many developments and tests of dental material as protective agent for dentin pulp complex in dental tissue engineering. Biomaterials such as bioactive glasses, beta-tricalcium phosphates are suitable for bone as its chemical composition similar to dental hard tissue and also its iconic dissolution that could promote the cells towards a path of regeneration and self-repair. Is classified as Class A biomaterial that is able to bond with both hard and soft tissues such as bone and teeth. The bioactivity of Bioglass is represented by the formation of hydroxyapatite and hydroxycarbonate apatite layer on BG surface when it dissolved in simulated body fluid. The BG is widely used and being studied especially in dental applications for restorative and endodontic therapy. Recently, BG has been studied for dental desensitizing agent, dentin mineralization, antibacterial purposes, and inorganic fillers. Beta-tricalcium phosphate is an attractive biomaterial owing to its excellent biocompatibility and non-toxicity of its chemical components. It has attracted substantial interest in dentistry, orthopedics, and medicine during the previous decade due to its chemical composition similar to dental tissue. Its compounds are widespread in nature and biological systems. The aim of this preliminary study to investigate the potentiality of bioactive glass and beta-Tricalcium phosphate combination for dental tissue engineering. Materials and methods. Synthesis of 4,5-S5 bioglass by Sol-Gel method. To synthesize BG Sol-Gel method, first need to prepare 50 ml of nitric acid. Then all raw materials was added and left stir for overnight to make gel form. The solution was aged and dried gradually 36 degrees Celsius, 60 degrees Celsius and 110 degrees Celsius for 7 days. After 7 days, the powder was sintered at 600 degrees Celsius for 1 hour. Later, the granule was crushed and shipped with 50 micron sheet. The wet milling method was performed to synthesize beta-Tricalcium phosphate powder. Dicalcium phosphate dehydrate and calcium carbonate powder were mixed with ethanol in a zirconia ball mixer at 200 rpm for 6 hours with calcium phosphate ratio of beta-TCP at 1:5. Following, the slurry was dried in an oven 60 degrees Celsius for overnight. The dried powder compressed in axially using a hand press machine to obtain pellet and heated to 1100 degrees Celsius for 6 hours. Then the beta TCP pellets were crushed and shipped with 50 micron sugar. To synthesize BG beta TCP composite by wet milling method, 48% BG and 68% beta TCP powder were mixed with ethanol at a ratio of 4:1 liquid and powder. The mixing was conducted using zirconia ball miller at 200 rpm for 6 hours. Then the slurry was dried in an oven at 60 degrees Celsius for overnight. Then the next day, the dried powder was shipped and achieved particle size less than 50 micron using shiver. For characterization, the X-ray diffraction analysis was carried out using Bruker D8. The X-ray fluorescence was used to determine composition of oxide and oxide exist in materials. The scanning electron microscopy was performed to investigate the surface of materials before and after immersed in simulated body fluid. Particle size analysis was performed using wet laser diffraction method. In vitro bioactivity test was performed by immersing the materials in simulated body fluid with a dose of 2 mg per ml. The pH was recorded at design time point. Results and discussions. The particle size ranged between 0.4 to 86.4 micron that indicates the micron size composite materials. Moreover, 90% of BG beta TCP composite particle size is smaller than 32.4 micron. The exciting spectrum of BG beta TCP and BG beta TCP composite showed several formation of crystalline peaks. The main phase was sodium calcium silicate known as combate for BG and wheat logite for typically known as beta TCP was primary phase in both pure beta TCP and BG beta TCP composite. Wheat logite is a major mineral in heart tissue in animals. Its proportion in bone minerals is estimated to be approximately 20%, while in dentin it ranges from 26 to 58%. Due to the similar chemical composition of heart tissue, wheat logite or beta TCP has excellent bioactivity, biocompatibility, and bonding with bone and dental tissue. Interestingly, while BG incorporated with beta TCP, the crystalline peaks intensity of beta TCP is reduced, and the minor combate phase had also been outlined in BG beta TCP composite. The combate phase formation significantly influences the bioactivity which generates high which generates hydroxyapatite formation after immersion in simulated body fluids for 1 day and also had an evidence of precise antibacterial effect. The oxides estimated by XRF analysis based on weight percentage, while Bg incorporated with beta TCP, it reduced the oxide primary weight percent of pure Bg and beta TCP. The network connectivity value of Bg beta TCP composite is 2.037 when enumerate the equation based on XRF result. It is widely known that network connectivity value has been used to predict the characteristics of silica-based materials. When the network connectivity value is close to 2, the rate of epithet deposition and newly bond formation increases. Surface structure of Bg beta TCP and Bg beta TCP composite before and after soaking in SBF is shown in this figure. The particle shape in all of samples were found to be irregular with small particles appear to agglomerate each other. The feather-like crystal shaped hydroxyapatite rough surface appear on pure Bg and Bg beta TCP composite surface after 1 day of soaking, whereas the crystal-shaped hydroxyapatite appear on pure beta TCP on day 7. To test bioactivity, SBF is the most effective in vitro testing method for apatite formation, while the Bg incorporated with beta TCP, which may help to improve the bioactivity of composite based on hydroxyapatite formation on the surface of day 1 after immersion. Since the XRD spectrum also recorded before the evidence of combat phase in Bg beta TCP structure, which is supremely bioactive. Moreover, after first day of immersion in SBF, the pH increased in Bg beta TCP composite due to the sodium, calcium and phosphorus ion released in the solution and exchange with protons of dissolution. Whereas beta TCP showed decreased trend of pH at the same time point. The ion released faster in low pH initially, then becomes steady over the time elapsed. In an experiment, Bingle et al. Examined in pH 7.3 condition, the ions from Bg released significantly and suggesting that the ions exchange happened significantly faster in compared to pH 9 condition, which is the possible explanation for rapid ion release in Bg beta TCP composite and hydroxyapatite formation appear on the first day of immersion. Conclusion. In this study, sol-gel bioactive glass was successfully incorporated with beta TCP to develop glass ceramics based on composite. The mechanical and physical characteristics were investigated for evaluation of potential bioactivity. The network connectivity value predicts its distinguished bioactivity, and while exposed to simulated body fluid, the dense hydroxyapatite layer formation on the surface of the composite, which indicate that it has excellent bioactivity characteristics. Therefore, Bg beta TCP composite expected to have the ability to dental tissue engineering. These are the references I used in my slides. Thank you very much for having with me.